we have learned that displacement is equal to final position minus initial position. Velocity is equal to displacement by time taken. So it is displacement by time taken. Acceleration is equal to change in velocity by time taken. So we see that all these terms, acceleration, displacement, final velocity, initial velocity, time taken, all these terms are interrelated. But what is the nature of relationship between these terms? And how exactly are they interrelated? Given some of these terms, how do we find others? In order to solve this problem, we derive the equations of motion. For deriving the first equation of motion, let us ignore displacement for the time being. So, let us try to find a relation between initial velocity, final velocity, acceleration, and time taken. When I say final velocity, initial velocity, time taken, acceleration, does some formula come to your mind? Yes. Actually, this is the formula for acceleration. A is the acceleration, which is equal to final velocity v minus initial velocity u divided by time taken t. Let us assume acceleration to be constant for the time being. And let's see what happens. So simplifying this equation, we get a into t is equal to v minus u. So this is what we get. Now, if we add u to both sides, we get u plus at is equal to v. So we get v in terms of initial velocity plus acceleration into time taken. So v is equal to u plus at, and this is nothing but our first equation of motion. Final velocity is equal to initial velocity plus acceleration into time taken. Now, what is the intuition behind this first equation of motion? We know for anything, final is equal to initial plus change. So, we have final velocity is equal to initial velocity plus change in velocity. We know that acceleration is equal to change in velocity by time taken. Change in velocity is given by acceleration into time taken. So we get final velocity is equal to initial velocity plus acceleration into time. Let us try to understand it with the help of an example. So we have an object whose initial velocity was 10 meters per second, and it is moving with a constant acceleration of 1 meters per second square for 5 seconds. So, it started with a velocity of 10 meters per second. Its acceleration is 1 meters per second square. That is 1 meters per second per second. So, its velocity is changing by 1 meters per second every second. So, in 5 seconds, by how much has its velocity changed? Into 5 seconds? So, in 5 seconds, its velocity has changed by 5 meters per second, which we get by multiplying acceleration with time. So, this is the change in velocity, and this is the initial velocity. So, what will be the final velocity? Obviously, initial velocity 10 plus change, that is 5. So, final velocity will be 15 meters per second. So, the sense is that when the acceleration is constant, we can multiply it with time, because for each time period the acceleration is the same. To get the change in velocity, add it to the initial velocity to get the final velocity. Note that we cannot do it if the acceleration is not constant, because then for each time period or each instant in time we'll have different accelerations. So we cannot multiply a single acceleration to the entire time taken. So the first equation of motion relates acceleration, final velocity, initial velocity, and time taken. Given any three of these terms, we can find the fourth one using this first equation of motion. And another important point to note is that equations of motion are valid only when the motion is in one dimension. That is, the body is moving along a straight line and the motion is uniformly accelerated. That is, the value of acceleration remains constant. They do not hold for non-uniform acceleration. So let us answer a simple question here. A train started from station A and reached station B in 2 hours. The initial velocity of the train was 0 meters per second. Acceleration of the train was 50 meters per second square for some part of the journey and 80 meters per second square for other part of the journey. Can you find the final velocity in meters per second using the first equation of motion? Well, here we see that acceleration of the train was 50 meters per second square in some part of the journey and 80 meters per second square in some part of the journey. So acceleration is not constant. We have already learned that equations of motion are valid only when the acceleration is constant. So we cannot use the first equation of motion to find the final velocity. Now we can also derive the first equation of motion using graphs. So let us see how can we derive the first equation of motion using graphical method. This is a velocity time graph. At time t equal to 0, initial velocity is u. Total time taken is t. And at time t seconds, the final velocity is v. So we get initial velocity is given by u, final velocity is given by v, and time taken is given by t. We know that slope of a velocity time graph gives us acceleration. So slope of this graph gives us acceleration. Let us try to find the slope of this graph. We have learned that to find slope, we need 2 points. So let us take 2 points, point A here and point C here. So we have taken 2 points. Now we join this and we join this. We mark it as B and mark this as D. We drop a perpendicular from A to the x-axis, mark it as B. We drop a perpendicular from C to AB and mark it as D. Now let us find the slope of this graph. For finding the slope, we take 2 points C and A and we move from left to right. Now slope is equal to rise by run. So in moving from left to right, that is from C to A, what is the rise? From C to A. The rise is this distance between A and D. So the rise is AD. What is the run in moving from C to A? That is the horizontal distance. It is this distance, which is equal to CD. What is AD here? Well, AD can be written as AB minus BD. It is AB entire thing minus BD gives us AD, and we write CD as it is. So this is what we get. Now what is AB? AB is equal to V here from 0 to this point. This entire thing is V. So from B to A, this entire distance will be V. And what is BD? from 0 to this point, this distance is u. So this distance will also be equal to u. And CD is equal to from 0 to t. Distance from 0 to t is t. So this is what we have. Now, we know that slope of velocity time graph is equal to acceleration. So acceleration is equal to v minus u by t. Now simplifying this, we get at is equal to v minus u. Now, if we add u to both sides, we get v is equal to u plus at. So v is equal to u plus at. This is our first equation of motion. V is equal to u plus at, and hence we have derived the first equation of motion using graphs. Now let us try to solve a numerical using the first equation of motion. It says a car moving with a velocity of 20 meters per second stops in 10 seconds. What is the acceleration? Now a car moving with a velocity of 20 meters per second. So this means our initial velocity is 20 meters per second. It stops in 10 seconds. So time taken is 10 seconds. We have to find the acceleration. Now what is the final velocity? We know that first equation of motion is v is equal to u plus at. We have u here, we have t here, we have to find a. What is v? It's given that the car stops in 10 seconds. Now whenever you see the term it stops, you can infer that the final velocity is 0. So it is not necessary that a numerical will tell you that the final velocity is 0 meters per second. Even if it says that the car stops, we can infer that the final velocity is 0 meters per second. And now we simply have to plug in these values in the formula. So v is 0. 0 is equal to u is 20 plus a into t is 10. So this is what we have. 0 is equal to 20 plus a into 10, or we get 20 plus 10a is equal to 0. Simplifying this, we get 10a is equal to minus 20, and a acceleration is equal to minus 20 by 10, which is equal to minus 2 meters per second square. Since all the units are given in meters or second, then so the unit for acceleration is meters per second square. So this is our final answer. Acceleration is equal to minus 2 meters per second square. Here we see that it is a retardation because the car initially had some velocity and then it stopped. So it slowed down with an acceleration of minus 2 meters per second square, and this is a case of retardation. So we have seen that this is our first equation of motion, which relates final velocity, initial velocity, acceleration and time taken, and given any three of these terms, we can find the fourth one using the first equation of motion.